everyone, and welcome to Geograph's session of webinars. This is going to be the first of 3 webinars that we are taking part in this week. We're doing this in conjunction with the Esri IMGIS conference that is going on presently. Appreciate you guys that are attending that jumped over to view this webinar. We hope you find this informative, and if it spurs any questions or comments, please feel free to jot those down in our chat session. We have moderators, both TJ and Gray, that will be standing by to help address your questions. If you want to take this a little further, deeper offline, please don't hesitate to contact us afterwards. And we look forward to your comments and questions related to this webinar today. First off, let me introduce myself to those of you who may not know me. My name is Bruce Smith. I'm CEO here at Geograph. I've been in the telecommunication business for 22 plus years now. Worked with everything from copper to fiber to coax. One of the things I learned as coming up through the telecom industry is just how big of a need there is for systems of record and management systems that not only manage your fiber, but also your legacy plan as well. Copper and fiber seem to be the leader in the industry for communications, but HFC, or hybrid fiber coax systems, are somewhat of an oddity nowadays. There's still a lot of systems and a lot of people that are using it because it's a great technology that delivers the broadband needs of today. And you need a state-of-the-art system that can help you not only design HFC plant, but also manage it as well. So we're going to take a little bit of time today and talk about how CrescentLink, our extension for Esri ArcGIS Desktop, can help you not only manage your fiber plant, but also your HFC plant. So with that said, let's talk about a little bit about what we're going to look at over the next 30 minutes. If I can get our PowerPoint to move. There we go. So one of the first things that we're going to talk about is managing your HFC plant with CrescentLink with the CrescentLink extension in the ArcGIS Desktop. So what do we mean by managing hybrid fiber coax? There's one thing to have the documentation. There's another thing to do the design and the flow and the calculations. But once you actually have the plant built, you want to manage it. You want to manage your assets, your actives, your passives, your customers, your connections. You want to be able to troubleshoot that. And so there's a lot of things involved with managing your coax network, things such as symbolization, power management, the visualization of information about your network, and the ability to locate and understand and troubleshoot your network. We're also going to talk about your network profiles and specifications. HFC networks are a complex puzzle of devices that must be put together in a way that delivers signal that brings the quality of services to your end user. The shape and size of those puzzle pieces are key to designing a stable network for today's broadband networks. So we're going to review aspects of not only power, but also flow calculations within the tool as well. And lastly, we're going to show you how to take all of those and plan and draw those designs within the Esri ecosystem. To go back to the start, to the management part of your network. So when we talk about plan and drawing designs, we're going to talk about creating the lines, the points, the connections, the symbology, and then load those designs into the map, not only for a first-time use, but also to be able to access them later on if you need to do line extensions or updates to your maps. So without further ado, let's jump in and take a look at how CrescentLink and the ArcGIS Desktop manages your coax network. So what we have here is a small HFC network model. You can see here that we have fiber coming into a fiber node, then leaving out on the coax plant portion of the network. Now, as we talked about, symbology is very important for the HFC network. Historically, coax networks were built on CAD platforms without a lot of intelligence. So being able to understand not only the size taps you had, the type of amplifiers or line extenders you had, maybe even the couplers that you were using, you had to symbolize those to understand that. With Esri, we don't want to lose that integrity of that symbolization that you guys have come accustomed to knowing. So you have the ability to not only symbolize your network, but also to manage it. So things such as power supplies, amps, amp stamps, node stamps, tap stamps, taps with size and dB losses, all of the symbolization that you're used to is still available for you within the Esri platform. Looking at this, you see how we have these categorized, and we have these to where we can import these layer files if you're starting up a new map, and you don't have to recreate those, but you also have the ability to change colors or symbolizations as needed, depending on how important your symbolization of the maps are. So when we talk about management of the system, let's talk about first the fiber part of it. So I want to come back up here to our node where we have fiber coming in. And let's look at how CrescentLink can work with both fiber and Coax for the management of your network. So we're going to start with our CrescentLink Network Manager here, our first button on the toolbar, and we're just going to select our fiber. We can see that it changes colors and we have a list of the fibers. So this is a 48 strand fiber that's coming into this node, but you can see here that the tips of these fiber strands are all referenced as gray right now. This is just giving us information of the fiber that's coming in. We can see the color codes and the strand numbers. We can also see that this fiber is running approximately a little short of 3,000 feet to its location. We also have information about the fiber, such as its ID, maybe its fiber name, or we could put counts on this. There's lots of things that we can do from this window, but what we want to do is see what is actually working on this fiber, what's going into the fiber node, and what would be affected if this fiber went out of service. So I just simply want to click this button here, which is a trace all for the fiber. What this is going to do is run through every strand of fiber and trace it from end to end. Now you can see that our colors changed on the tips of our cable. We have one right here that's yellow, the second one is red, and the rest are black. What that means with the yellow means that there are active circuits actually working on this fiber, and we can see that there's 41 active circuits that are showing up on this single strand of fiber. The second fiber here says that there may be equipment on one end, so maybe this is taking off from your CMTS back at your head end or your equipment, but it's just terminating at the node and is not spliced to the piece of equipment. But this first fiber has 41 circuits, so we know that this is the active fiber that is actually powering our node. So let's take a little bit deeper dive into what this fiber represents. So if we expand this, we can actually see every terminating location within this node's network on from this single strand of fiber. We can see ones that are terminating at the branches of the node where we don't have plant. We can see them where they terminate on taps. And which drop of the tap they're actually terminating at and the location of that tap. And we can also see circuits that are actually going to house locations. So here we have one at 72 Melody Lane, 67 Melody Lane, and so on and so forth. Another bit of information that comes along with this is the distance. So this is running 28,339 feet approximately, and that's coming all the way from the head end. So that's running through the fiber and the coax all the way to the terminating location, the tap name and the drop on that tap. So a good bit of information that we can look at here. We can also look at a trace diagram of this. So if I click on this one that's terminating at a location, and I'm just going to squeeze this up so we can take a look at this on the map. We can see the trace results over here for that single circuit that's terminating at 67 Melody Lane. We can see that it originates at the head end, the patch panels that it goes out on, the fiber strands that it goes out on, all the way to the fiber node. Then we can see that it's on branch 1 of the fiber node, and then the coax plant and taps, amplifiers, couplers, power inserters, all the way down to the tap that this location is being fed from. A couple of things we can do from this screen is we can zoom to that location and you can see it represented here. We can also right click at the very top and zoom to this entire circuit so that we can see this circuit identified from the head end all the way to the terminating location here at the house. So if we wanted to take a little bit deeper look at the house location, I want to zoom to that location. For example, maybe we've got a complaint or an outage that their service is out, or they're not receiving quality of service like they expect. And so you need to find out a little bit about what's going on. So now that we know the location of the house and we can see all the connections that this runs through, we have a visual interpretation of this connected circuit from beginning to end. We also can look at the location itself to gather some information about the terminating point here. So I just right clicked on the address, and I'm going to go to the Network Manager button. And this pulls up this neat interface here that's part of the CrescentLink. We can embed pictures or files to the location. So we may have a location of the terminating box there. We can have all the equipment that's associated with this equipment. So right here, I'm listed a cable modem. The attributes that we can attribute to that location. So we know it's a cable modem, it's existing, it's a Cisco wireless modem. Maybe you have a model number, the IP address of the modem perhaps you'd want to capture. Maybe a phone number or an account number that you'd like to have. And any specifications that you would want to have with that associated with that location. So I've got a little ghost box down here that's keeping me from doing anything else. But so if we wanted to scroll down, we could see all the different information here. And then we can also see the cables that are coming in here. So I've got a coax cable that's coming in. So if we had started originally from this location, we could also trace from the coax back, and we would get the same information results that we did tracing from the fiber out. So all this information is kept seamless within the database that you can manage your network by. We can also use the same tools. We don't have to have different tools to do the exact same thing on the coax. So let's suppose we have a damage to our coax line right here, which we can see is an 875, I believe, an 875, yeah, coming into here. So we're just actually going to click on the coax strand right here. We're going to do a trace on this cable. Now this is going to take a little bit longer because this is feeding all the circuits that we talked about earlier. You can see that there's 132 legs. Well, that means there's ports associated with that as well on your taps. And you can see the addresses of the terminal locations. All the information that you would need to understand. Here again, we have from the MT to 67 Melody Lane. And we can see that same trace feature that we saw earlier. So that's one way you can use the tools to manage, troubleshoot, and visualize your plant network. Now that's all fine and good, but what if the system is just not operating correctly? So not only do we want to visualize the connections and the services and the circuits that are on this network, but we also want to understand the, again, as I referenced, the puzzle pieces that actually work with this network. So all of these devices, the amps, the splitters, the couplers, the distance of cable, the size of the cables, all of those affect the quality of your network and what that means. So what we've developed here is our Coax Designer is a function within the toolbar, comes with CrescentLink, it's not something extra. And this is where you actually design and manage the science of the network, I would say. And the way we do that, we have a couple of options here. So we have profiles. So what is a profile, you ask? A profile is where you may have, in the HFC, it's common for companies to buy up maybe smaller coax plants around, and maybe there's different specifications. So one may be a 1,000 megahertz, one may be a 750. You may have some older ones that are 550, 600 megahertz systems. So you may have different systems with different specifications that you're having to manage. So by being able to manage multiple profiles, we can set our specifications to those exact profiles. So right now I'm looking at my active profile, which is profile 1. You can see here that I've got it as the active design profile. So I'm using the specifications that are actually tied to this profile. But this could be done by area, it could be done by technology or equipment, however you want to set up your profiles. In the profiles, we have our specifications. So this is where you set the parameters of your network. So things such as your general parameters. So you want to do distance in feet or meters. Your signal is in decibel levels. Power interpolations. I can't speak. Your inline equalizations, max cascades. Your frequencies. So your forward highs, forward lows, forward returns, and the value of these. And then your tap levels, so your power levels for your tap and the range and margins of what you want your design to fall within at these different tap levels. We can move on through and label our amplifiers, different cables, equalizers, splitters, taps, all your two-way taps, your self-terminating taps, 4 ways, 8 ways, all your dB levels and taps, your pad banks, power inserters, power blocks, power supplies, and then any other specifications that you may want to add. But this is where you basically set up the backbone of your profile and your network to be able to do your design. These can also be edited or changed or add to just by simply clicking the button up here to add a new. Maybe you want to delete one if it's no longer in service, or you may want to edit a specification if things have changed. So as you can see here on our cable, we have 3 different types of distribution lines: a trunk line, some drop cables, loop resistance that we have here, and then a specification ID. So having all that, what does that mean? Well, if we want to look at our existing design here, so our existing plant, we may be having trouble with this plant and we kind of want to see what's going on with this node. We have a couple of options. We can load a design either from a saved draft. Maybe you're doing a new design in a new area and you haven't had the chance to build it yet or to put it in the map, but you've saved your draft. You could do it from a saved draft. What I want to do for this one, though, is load it from a map feature. So I'm just going to click on map feature here, and I can really just click anywhere on the network, but I'm going to click up here coming out of the node. And so what this is doing is running through every facility on that node, and it's listing it here in a kind of tree and branch hierarchy. So if we collapse this, we can see coming out of our fiber node here, we got 4 branches. Branch 2, 3, and 4 don't have any legs on them. We only have 1 branch populated here. But if I expand that, I can see all the different parts and pieces of my network starting to come together. So I have an 81-foot span of 875 cable, straight splice, a 92-foot span, a line extender amplifier, a 93 span, a coupler, and then when our couplers, we branch off. So we have branch 1 here. The other branch falls down to this cable. We have our power inserters, our power supplies, all the way through. And so we can look at any one of these devices and we can see the information about the signal or the system at that level. So as you can see here, our return low, return high, and forward low are out of spec. They're too low. Forward high is marginal. And this is where you can look at your design to see if you need to update anything. You can also hover over it to see your tooltips, as you can see there. Again, expanding or collapsing these to be able to manage within the system. We can also zoom to these locations. So if we wanted to go to this tap and zoom to that location, we simply right-click, zoom to that tap location. So you can see it's a 4-way 11 dB tap. Here's our tap calculations for our forward high, forward low. You can see right here the representation. I believe that's yeah, right here. So your forward low, your forward high, your return high, and your return low calculations are showing here on the map. If you don't want the tap calculations, you can on the taps, you can do these individually, where you come in here, to the equipment, and this button right here says edit tap stamps. So pull this back over here to the screen. We can see our levels here. And if we want to turn that off, we can simply just toggle this button on or off to turn that display off in the map if we don't want to pollute our maps with the taps. Or if we wanted to go to our table of contents, we could simply, here's our display of our stamps. We could simply just turn our stamps off for the entire system and then turn them back on when we want to. I've got them set up to where I can zoom in and zoom out. So at certain levels, the stamps disappear, but then when we zoom in a little farther, they come on. So a lot of neat things that you can do with that. Okay, minimize this back and get back to our design here. So that's a way that we can load an existing design or a draft design from the map to get our calculations and information about our network. But maybe we want to add to this. Maybe we want to build a new design. So I want to come into branch 2, and I'm just going to kind of build a mock design, of this leg up to these 2 houses. So on branch 2, what I want to do is right click, and I want to add a specification, add a device. So first off, I'm going to add a cable span, and I'm going to add 750 cable, select. So what this is going to give me is the distance of cable that I want to add. So let's just say that's 250 feet, and the house count that I'm going to be serving. This is important for our tap calculations. So I'm going to say I'm serving 2 houses at that location. Now I could set my tap level here. Let's leave it at a 0 so it comes out pretty hot, and I'm just going to say continue. So you can see that the span has added here, but there's a little button here that says needs to be placed in map, and we'll get to that in just a moment. But what I want to do now is I want to calculate my tap for that. So as I told it, it's 250 feet and I got 2 houses. So I want to right click again on that span of cable and say calculate taps. So what it's going to do is look at my signal level there and the requirements for that house, and it's going to make a recommendation of a tap that I need to use. So it's recommending a 2-port 23 dB tap. If I look at that, my forward high is marginal. This was probably okay, or I could change this if I personally wanted to not take the design and maybe I wanted to put a 2-port 18 dB. I can come in here and update this, go to my taps, and let's do a 2-port 20 instead of a 2-port 23, see what that does. So if I come in here, my forward high now has gotten worse. So I may want to go back, update that again, and go to a 26 maybe. Still not quite right. That one's probably worse, but my forward high is good at that point, but we'll leave it for now. If I wanted to extend this, I could just keep adding devices to this. So I want to add another cable. Let's add another span of cable, maybe a 100 feet this time, and that's going to go to 3 houses. Continue. Want to add a coupler at this point in time. So we'll expand this so we can see the details of it. So I'm going to put a DC12 in here. And now I have 2 branches here on my coupler that I could add, again, cable to. So on and so forth. And then when I get all of this kind of designed out, if I want, I can go back in here, do a calculate taps. You can see it made the tap recommendations based on ones that are closest to spec for that. And so now what I want to do is I can either save this design or I can start adding it to the map. So what I want to do is add this to the map. So I'm going to right click and say place in map. Now what that does is gives me it actually picks the template that it wants me to draw. So I'm going to just start drawing my cable out. And if I wanted to set that limit, I could hit a Control L and do 250 feet. And you can see that now is setting that limit of that cable to 250 feet. And I could just click right there, hit finish sketch. And you can see it puts a connection joint there. So now I want to add my tap. So I just want to place in map, click there. And if we zoom in, we see our tap right on top of that. And with that being the display, what I can actually do now is take my display, and if I wanted to offset it, I could offset it, or I could leave it on top of the cable, whatever your preference is. It's already associated to that location. Again, I could take the cable, place in map, hit a Control L, 100 feet, and set my 100 feet, finish sketch, take my tap, place in map. And so you just go through your design and you just add your design to your map as you go. And so what that allows you to do is quickly design your tap, look at your calculations, make your updates as necessary, add your devices based on your specifications, and then quickly add that to the map. And so if I clear this design, it's going to ask me if I want to clear, because it's going to clear out that design. My information still stays there for for the plant that I put together. And then if I want to load this again, I'm going to load from the map feature, and I'm going to click from this location. Because everything is connected, when I add that to the map, my information shows back up in my designer here of what I added to the map. So it's a great way and a great tool to be able to not only do your designs, your calculations, your planning of your HFC network, but also add it to your map, and being able to continue that through to the management and the life cycle of that network, not only through the design, calculations, flow, and power specifications, but all the way into the maintenance and customer service of your network. So with that said, I don't know if there's any questions that's come in. I know we've got some moderators. If there are any questions, we'll be glad to answer those. If not, please feel free to reach out to us at your convenience, and we'll be glad to help you with any training, questions, or comprehension that you may need as it relates to our HFC tools. DJ, Gray, any questions come in or anything to add?
No, we're good, Bruce. I appreciate it. And
all right. Well, we look forward to everyone continuing on with our webinars this week. Again, DJ, would you like to remind us when our next two webinars are that everyone can join?
Yes, absolutely. So we are going to have, the first one is going to be coming up, and I apologize, I'm in Eastern time, where a lot of you are in Pacific, or we're going by Pacific. But so the first one will be how to manage network outages with ArcGIS Desktop and CrescentLink. That'll be at 12:45 Eastern. And then the next will be how to estimate project cost using GIS. I'm really looking forward to that one. Gray's going to be doing that presentation, showing how to kind of automate your material units and get your cost done utilizing Project Planner. That's tomorrow at 1:45. So 12:45 and 1:45 Eastern tomorrow.
Yep. And before you end, it looks like we did get a question about handling drop conditioners at the tap. Chris, that's a great question. To be honest with you, I'm not as in depth on HFC design. We do have that capability for conditioning taps at the tap level, and I'm sure we can create an active device that would do that. Probably like to speak with you offline a little bit more on that technology to see exactly how to model that. But yes, that capability is there, and we do actually get asked that quite a bit.
Thank you, Chris. We'll reach out to you. Any other questions before we go?
All right. Well, everyone, thank you for attending. Thank you for your attention. If you are joining the IMGIS conference, good luck the rest of this afternoon, and hope you find a lot of good sessions that help you out. Take care.